Okay, so this is our roof geometry question here in the book. We're kind of looking at this now, but like, what does it mean? Okay, so we're after looking at the hedral angles, we're after looking at developments, but this here now, you can kind of see that they're folding out stuff and they're looking for the hedral angle, but what are these rectangles and triangles that are on the page here? So if we take a look here, these are all houses where I'm living at the minute. These are all the roofs on the houses. You can see that there's all these different shapes and sizes, and curves and drops and pitches and again, like if you kind of look at it, it is all kind of rectangles and triangles. Okay, so we can then switch over here now to Google Maps. We can see that this is the area that we're looking at here. This roof here in particular, just this section here. So if we zoom in, and give it a second there to load. Okay, so we can see now that this is what we're looking at here. Okay, so look, we've got a pitch, we've got a cross top here, and then if I go back out then a small bit, we can then get to see then our plan here of this roof section, just this section right here. Okay, and here then we have the model of the roof in SolidWorks. So if we look in from above, we'll see what we saw on Google Maps, which is this kind of layout here. I have all the different surfaces colored in different colors, you've red, blue, green, yellow. And then if we have a look then from a different angle, which is what we would have seen from the street view. 1 second. Okay, so that's what we would have seen from the street view. So here's the arch here above the two windows, and then this is just the flat part that we can see. It looks like a big rectangle. Okay, so as you can see then there's two major differences. And what we can also do is look in from the end here in this. So what we see then is this is our arch here, and then this is our front section here. Now, what does all this have in common with the hedral angle and developments? Well, let's say we were building this house. We need to figure out if we were to put in a bit of timber along here, and then another bit of timber along here, what's the angle that's going to be between them, okay? So by looking at that, it kind of looks like just maybe just over 90 degrees or so. But we can't be certain. We have to be able to figure that out some way. Same's going to happen for in here. So when we're looking in here, we need to put two bits of timber in along here as well. And we also then need to go around this corner. And we maybe need to put a bit of bracing on around here as well, at whatever degree this is at. So we're going to have to be able to find out what those angles are through graphical drawing. What we can also see then as well, so this brings us back into the developments. If we look down from the top and then we see the surface, okay, so this surface is not true shape. So in order to actually figure out what this shape looks like, we need to look at it straight on. So now we can see the true shape of that surface. Okay, same with this one over here. This one here now is not true shape. So what we have to do is we have to look at it bang on, dead straight, so we're looking perpendicular to the surface to find its true shape. It's the same for every single one of these shapes. They're all at a slightly different angle, so the true shape all has to be looking perpendicular. By doing that as well, then we could look along a line, so we could look straight down along this line here, and then we can see our dihedral angle between these two surfaces, okay, and we could measure that then as well. And then the same if we wanted to have a look at the other side, there's our dihedral angle here between them two surfaces. And then let's have a look then at the blue and the red. We'd have to look at along here, straight down along that line. There we go. Okay, so now there's the dihedral angle between them surfaces. But how do we then bring that on to graphical? How do we actually draw that? Okay, and so here we are then in AutoCAD with the elevation and the plan of the roof geometry that we were looking at there a couple of minutes ago. So this is our layout, and then we can turn on these layers here, and we can then see exactly what it is that we were doing with those layers. Okay, so this one here is to find our true shape of this surface. So we just use the rebatment method, swung it down, brought it straight down, and then we've just lined up our dots here. So we brought this straight out where they meet, bring it back, and then those are perpendicular. Then for our dihedral angle, we have taken a first auxiliary of this line out here to x1, y1. So that's the true length. This line here is the true length line of the intersection of the two lamina. And then we have another auxiliary coming out perpendicular to this line, straight out here. So there's the meeting point, and then there is our two lamina there. And we can see then that we have our exact angle. If we pop up here for a second, we can come back down, we can actually then measure that. Okay, so we know that it's 122 degrees between each of those surfaces, or each of those lamina. So when we're putting in our joists, then we know that we could cut each one of them to meet at 122 degrees. This way we'll have accuracy, and we will have precision in building the roof, in having correct support for the roof, and so on. This will be done on every single intersection on the roof, so obviously the more complex the roof, the more intersections. Again, we can then move back to what we had up here a second ago. This true shape. So then this will also then allow us to work out the total area of the roof and to find out how many tiles exactly we need for each section. This is going to be important as well for these bigger sections too, because if we're looking at them here now, they're not quite true shape. So we might be 3 or 4 or sometimes 5 rows of tiles short if we just looked at this. So we have to be able then to turn around and actually look at the true shape of that to find out exactly what we need and find the correct area.